Hi folks, we're going to take a look at number 7 from the Unit 5 assignment. All right, so take a look at it here. So they give us the longest and shortest days in this city, and they give us the number of daylight hours when they occur, and they want us to determine a model for day length versus time starting on 12 a.m. On January 1st, 2018, and they want us to predict when there's going to be exactly 12 hours of daylight in these 2 years. Okay, so let's start with the model. So they give us the max and min directly. So we've got the max is equal to 14.693, and the min is equal to 9.632. So from here, we can calculate the A and the C values. So let's do that here. We've got 14.693 minus 9.632 divided by 2 for the, divided by 5. Now let's try again. Divided by 2, 14.693 minus 9.632 divided by 2, and that's 2.53. I guess I'll keep 2.531 since we've got 3 decimal places there. 2.531 is our A value, and now let's calculate our C value. So 14.693 plus 9.632 divided by 2 is equal to 12.163. All right, so next thing we're going to go for is our K value. So our period, it makes sense to take as our period 365 days since we expect this to repeat every year. So that means that our K value is going to be equal to 2 pi over 365. So the last thing we have to decide is our parent function and if there's any phase shift needed. So since they give us the maximum on the 21st of December, that's the one that's really close to the 1st of January. So I'll work with y equals cos x, okay, the one that starts at the maximum. And so here, if I think of cos x, I know it's going to look, or this is not cos x, but something that uses cos x as a parent function, but I want my maximum to occur on the 21st of December, which is earlier on. So I need to shift my graph by. So now we have to think, well, do we take as December 21st the beginning of the day or the end of the day? But I suppose it's at the end of the day that we'll have the daylight hours. So I'm thinking of going, from midnight of the 21st of December to midnight of the 31st of December. So that's 10 units. So we're going to shift it 10 units to the left. All right, so now I think we are ready to write our model. So here, if I say let y be daylight hours and let x be number of days from 12 a.m. January 1st, now we can set up our model. So we have y is equal to, well, the A value is 2.531 times the cosine of our K value is 2 pi over 365. And so, wait, sorry, little mess up here. Let's do that. Times x plus 10. Since we're moving 10 to the left. So x plus 10, and then our C value here is plus 12.163. All right, so there's our model. So now, in particular, what they want us to solve for is when the daylight hours is exactly equal to 12. So this is the equation now that we're going to be solving in part 2. Okay, so I don't think we need any of this here, so let's maximize that, and now let's solve this equation. So step 1 in solving a trigonometric equation is to isolate the trig ratio. In this case here, we can do it with opposite operations. So we have the cosine of 2 pi over 365 times x plus 10, okay, is equal to, well, here, let's get our calculator out. So we've got... So I'm just going to subtract the 12.163 and then divide by 2.531. So we've got 12 minus 12.163. Okay, and then divided by 2.531 is equal to negative 0.0644. Okay, and so now we're going to solve this. All right, so step 2 is to determine two values whose cosine is equal to this number here. So the first one, since this does not relate to a special angle, the first one is to use inverse cosine. So inverse cosine of our answer from before gives us 1.64. Okay, so one possible value for 2 pi over 365 times x plus 10 is equal to 1.64. Not surprising since it's negative, so we get something in the second quadrant. Or the other answer is going to be given by 2 pi minus 1.64. So 6.28 minus 1.64, and that gives us 4.64. All right, so now we've done step 2. Step 3 is to now isolate for x. So x is equal to, so I'm just going to be multiplying by 365, dividing by 2 pi, and subtracting 10. So let's do that here. So we have 1.64, so times 365 divided by 2 pi, which is 6.28, and then minus 10, and we end up with 85. And now we'll do the same thing here, 4.64 times 365 divided by 6.28 minus 10, and here we have 260. Okay, so it's going to have 12 hours of daylight time on the 85th day of 2018, on the 260th day of 2018 again. Okay, those will be the only times in 2018, and to get the times in 2019, I'm just going to add 365. So here, what do we have? We have 85 plus 365 is 450. And then here we've got 260 plus 365, which is 625. Okay. So if you like, you can go on some site which tells you what day of the year will be. I'll leave you to do that. But this is the solution to the equation. Okay. So just to recap, step number 1 was to determine the model. So again, max and min were given. We assumed that the period would be 365. We conjectured that cosine x would be the best one to use because the maximum value occurs near our starting time, which was January 1st. And we realized that we had to do a phase shift to the left. Once we had our model, we set up our equation. So the daylight hours being equal to 12. Step 1, isolate your trig ratio. Step 2, use inverse cosine and the 2 pi minus theta related angle identity to determine your initial two answers. Step 3, solve for x. Step 4, add or subtract the period in order to determine all the other possible solutions. Okay, that's it for this one.